Okay, we're at the 100 examples. Again, this is from black pen, red pen. I'm going to do them at the whiteboard, and I'll do it in pieces. I realize that a lot of times we're watching black pen, red pen's work. He does a lot of problems in a row. So I'm going to break it in chunks, and I'm going to do the definition first. Then we'll do recognizing limits as derivatives, and we'll go through the sheet like that. Again, it's a tough problem. Tough set of problems. We'll get through it. I'm going to go to the whiteboard now. Make sure you have access to this document, but I'll be writing it over again, and I'll be talking through it. The first question, this is example number 1. It says that f of x equals 2009. By the way, reason he's using 2009, this dates back to 2009. There's 100 examples on the derivative. He says use the definition. Well, let's write that down. So f prime of x equals the limit as h goes to 0, f of x plus h minus f of x over h. Let's write this down. F prime of x equals the limit h goes to 0. And again, some students often get confused by this, but the function evaluated at x plus h is the same as the function at x because it's a constant. It's 2009. It's always 2009. Again, if you were to simplify that, limit h goes to 0, and you would get 0 over h, which would be the limit h goes to 0. By the way, h is not 0, so 0 divided by something that's not 0 is going to be 0. Limit laws, that's going to be 0. So that derivative is equal to 0. Let's go to example number 2. And example number 2 is f of x equals x squared plus 3x. Well, they want to use definition again. Again, a couple of things I need to know. I need to know what f of x is and what f of x plus h is. So f of x plus h is x plus h squared plus 3 times x plus h. That's x squared plus 2xh plus h squared plus 3x plus 3h. Okay, from here I'm going to write down f of x plus h minus f of x. I'm kind of looking at that. Again, I want to point out what I'm looking at. I'm looking at these two things over here. And what I notice, like immediately, if I'm doing a subtraction, I notice that these terms are going to disappear. And what are you left off with? Something pretty simple. You're left off with, whoops, I didn't mean to do that. Oh, you know what? Maybe I should put the h down now. And what are you left off with there? You're left off with 2xh plus h squared plus 3h over h, all right? Now, what did you just do over here? We just did this. All right, what do I got to do now? Write this down. So f prime of x equals the limit. Again, this is preliminary work over here. This is work. H goes to 0. F of x plus h minus f of x over h. Well, we just did that. Let's write that down. Limit h goes to 0. And that's going to be 2xh plus h squared plus 3h over h. Now, as h goes to 0, it's not going to touch 0, so I can divide through by 0 without issue. So what do you get over here? Limit h goes to 0. You get 2x plus h plus 3. Let's see if I did that right. Yeah, 2x. Yeah, as h goes to 0, what are you left off with? 2x plus 3. All right, that's a derivative of that particular function. Let's go to the next one. And the next one is going to be number 3. And what do you get there? You get f of x equals 1 minus root of x. Well, I'm going to write this over here. F of x plus h minus f of x over h. I'm doing some side work, by the way. Looks relatively simple to do, at least to write it down, by the way. What are you going to get? 1 minus the root of x plus h minus 1 minus the root of x. Right, looking at that, yeah, say, what would you do with that? And I'm going to say, oh, something does disappear. I'm going to write this over here. The 1's disappear, and what are you left off with? Root x minus the root of x plus h over h. By the way, I'm not doing limit. I'm just doing some preliminary algebra. What I'm going to do now, I can multiply the top and bottom by the top's conjugate, which is root x plus h. Root x plus root x plus h. What do you get over here? Well, the conjugates are nice. You just get x minus x plus h. We'll do that later. On bottom, you get h root x plus the root of x plus h. What happens over here? You left off with minus h over h root x plus the root x plus h. So I just did some work over here. And what I want to do is write the definition of the derivative down. So f prime of x is going to be the limit as h goes to 0, f of x plus h minus f of x over h. And we just did that. Let me just remind you what we just did. We just did this. And what is that going to be? This thing over here. Well, let's write that down. That's minus h. And what do you get on bottom? H root x plus the root of x plus h. What's nice about this, h is not 0. You're just getting close to it. This disappears. And you're left off with a pretty simple limit. And what's that going to be? Minus 1 on top. And you get root x plus the root of x. What does this give you? Minus 1 over 2 root x's. All right? So that one's done. Let's go to the next one. And again, hopefully you have the sheet in your hands and you're working these problems yourself, by the way. And I guess we just did 1, 2, 3. Let me turn the page and we get to problem number 4 now. And it's a quotient. And it's going to be f of x equals 1 over 3x plus 1. Well, I'm going to do the preliminary work of f of x plus h minus f of x over h. Let's write that down. And you get h here minus 1 over 3x plus 1. And what do you get over here? You get 1 over, well, it's going to be 3 times x plus h plus 1. All right? So let me write this over here a little differently. H 3x plus 3h plus 1, that's a 1, minus 1 over 3x plus 1. This is a complex fraction. I can multiply the top and the bottom by the minor LCD, which can be 3x plus 3h plus 1, 3x plus 1. The bottom is going to be 3x plus 3h plus 1, 3x plus 1. But if you do that, what are you going to get? You have to be careful here. The bottom is h, and then you get 3x plus 3h plus 1, 3x plus 1. What do you get on top? 3x plus 1 minus 3x plus 3h plus 1. Well, it's going to ever end. It's going to end soon. What do you get over here? H, 3x plus 1. I'm commuting those factors around, by the way. And what do you get on top? Well, the 3x's disappear. That's good news. And the 1's disappear. And we left off with minus 3h. So let's write this down. The limit, we're getting the derivative here by the definition. The limit as h goes to 0, f of x plus h minus f of x over h. It's going to be limit h goes to 0. And I want to point out, we just did this part over here. We did the difference quotients right over here. Let me just explain that to you. We did that. It's really come from over here. We just went through that. And what do we find? We found it was minus 3h over h, 3x plus 1, and 3x plus 3h plus 1. All right? What do I know about that limit? H is getting close to 0, but it's never touching 0. So the h cancels off. And you left off something pretty simple. Minus 3 on top. On the bottom, you have 3x plus 1. And you get 3x plus 1. Let me clean that up a little bit. And it's going to be minus 3 over 3x plus 1 squared. All right? So that was number, I think we just did number 4. And we're going to go to number 5 now. All right, number 5. And again, we're going to do this in pieces. It's not going to be a marathon. Let's see, x squared minus 5x. And let's write down. So f of x plus h minus f of x over h, the difference quotient. That's going to be h. What do you get here? Well, you can get x plus h squared minus 5x plus h. Now, a lot of students, they make an error. They make an error in the subtraction department, but it's minus that function. So I'm going to put in parentheses, by the way. What I'm going to do now, I try to simplify that as much as I possibly can. What do you get there? X squared plus 2xh plus h squared minus 5x minus 5h minus x squared plus 5x. I'm kind of looking at it. Let me get my red pen out. And I know some things are disappearing. For example, this and this cancel off. And the 5x cancels off. And the question is, what are you left off with? Well, write that down. You're left off with 2xh plus h squared minus 5h over h. I'm going to do the limit now. I'm going to get the derivative by the definition. H goes to 0. And what do you get over here? You get 2xh plus h squared minus 5h over h. Well, again, h is not 0, so I can divide through by it. And it's going to be, whoops, sorry about that. I'll go backwards a little bit. It's a limit. H goes to 0. And if you divide through by h, you're dividing every term by h, you get 2x plus h minus 5. And that limit's rather easy to do. It's 2x minus 5. All right? So that was number, I got to remind myself what we just did. That was number, that was 5. Oh, you know what? I didn't follow instructions. Number 5 is find f prime at 0. I didn't do that, so let's put that down. It's going to be 2 times 0 minus 5. And what does that equal? It equals minus 5. All right? Let me get my eraser out. Did not follow instruction. I'm going to erase this. That was not their question. But it certainly helped me answer the question. Right? And again, by answering the question, an incorrect question, I shouldn't say an incorrect question, the question they didn't ask, it allowed me to answer their question. However, I'll be honest with you, there's another way of doing it. I'm going to go through that with you. So f prime of 0 could also be written this way over here. The limit as x goes towards 0, f of x minus f of 0 over x minus 0. And let's put this down. And again, it's going to be limit x goes to 0. What's f of x? Well, if you can't remember, you go back and read in the sheet. It was x squared minus 5x. I'll write that down for you. Minus, what's f of 0? You evaluate that function at 0, just 0. And x minus 0 is just x. So what do you get over here? Limit x goes to 0. You get x squared minus 5x over x. Well, what I know about the x getting close to 0 but not touching 0, so I can divide through by 0. I'm sorry, divide through by x. I misspoke. Again, x is not 0. So this question is going to be x minus 5. I can do the limit now by limit laws, and you get minus 5. All right? So I really start paying attention to the instructions over here. Let's go to example number 6. And number 6 is f of x equals x over 3x plus 2. And they want me to find, by definition, f prime is 0. Let's write down limit. Whoops, maybe I should write down what we're doing here first, right? My eraser out. So it's going to be f prime of 0. Let me show you I did that before. I did. All right, so f prime of 0 is going to be, whoops, I did it again. It's going to be a limit. The limit as x goes towards 0 of f of x minus f of 0 divided by x minus 0. Well, it looks pretty easy to do. X minus 0 is just x in the bottom. F of 0 is just 0. I'll write that down. And f of x is just x over 3x plus 2. I'm going to rewrite that. Limit x goes to 0. I'm going to write it as x times 3x plus 2. And there's an x there. And what do I know about this? I know we're going towards 0, but we're not going to touch it. So this really kind of cancels off. Let me get my eraser out again. Get rid of that. So it's going to be a limit. X goes to 0. This will be 1 because x is not 0, by the way. 3x plus 2. What happens when x goes towards 0? Limit laws give us a half. All right? So that one's okay. I guess we're on problem number 7 now. And what's number 7? It's a little different. F of x equals x over 3x plus 2. And they want f prime at 1. Let's write this down. F prime at 1 is the limit as x goes to 1. It's going to be f of x minus f of 1. I'm doing the same thing I did over here. Yeah, I'm doing the same thing. I want to make sure I'm being consistent, by the way. X minus 1. Let's write this down. Limit x goes to 1. What's f of x? It's x over 3x plus 2. Minus, what's f of 1? It's 1. That's what x is 1. The bottom would be 5. And that's going to be over, let's see, x minus 1. All right? What I'm going to do now, multiply top and bottom by the minor LCD. That's going to be 5, 3x plus 2. 5, 3x plus 2. What do you get over here? Limit. X goes to 1. The bottom is x minus 1. I see a factor of 5 and a factor of 3x plus 2. What do you get on top? Well, you're going to get 5x minus, put in parentheses, 3x plus 2. All right. I think I made a mistake somewhere, and I got to look at it. And did I make a mistake somewhere? Let's see, 1. The reason I think I made a mistake, I'm looking at it, and I'm seeing 5x minus 3x, which is 2x, and I'm seeing that might be, no, it's not. Let's keep going. What do you get over here? Limit x goes to 1. Let's see, 5x minus 3 is 2x plus, not plus, I'm really daydreaming here, minus 2. And what do you get in bottom? 5, x minus 5, 3x plus, oh, I see the problem now. I copied wrong. And I was wondering why things were not really working out. And I'm glad I look, and someone says, do you make mistakes often? All right? So I'm glad I have a chance to correct this. Because otherwise I'd get to a limit I couldn't do. 3x plus 2. All right? What about the top? Well, let's keep going. Limit x goes to 1. This is 2. X minus 1, 5. X minus 1, 3x plus 2. Well, I know x is not going to touch 1, so these are non-zero. And I'm left off with a much simpler limit. I'm left off with the 2, 5, 3x plus 2. I can use a limit laws now. This is 2. And the bottom, when we approach 1, it would become 5 times 5, which is 25. So 2 over 25. Let's go to example number 8. Make sure I'm doing this. Yep, number 8. And what do you get over here? Well, the f of x is the root of x plus 1. And they want the derivative at 8. Let's write this down. So f prime of 8 is going to be the limit as x goes towards 8. And it's going to be f of x minus f of 8 over x minus 8. Let's keep going through that. Limit. What's f of x? The root of x plus 1 minus, maybe my fraction bar is a little bit too long there. Well, if you evaluate that function at 8, what do you get? You're going to get the square root of 9, which is 3. And then what do you get in bottom? X minus 8. What I'm going to do, multiply top and bottom by its conjugate. And you may wonder why that is, because I can't do the limit as written. So it's going to be root of x plus 1 plus 3, the root of x plus 1 plus 3. Let's do that. What do you get? Limit. You get x minus 8, and then you're going to get the root of x plus 1 plus 3. Now looking at the top, it doesn't look that bad. It's just simply x plus 1, these are conjugates by the way, minus 9. All right? And I start to realize that x plus 1 minus 9 is just simply going to be x minus 8. Let me put that down instead. I put a factor symbol on it. I put in parentheses. And when I know x is getting close to 8 but not going to be 8, so these things cancel off. When we left off with limit as x goes to 8, 1, the root of x plus 1 plus 3. And I can use limit laws now. You get 1 on top. And on the bottom, you're going to get 3 plus 3, which is 6, so 1/6. All right, that's problem number 8. Let's go to example number 9. And number 9 is another definition problem. So it's 1 over root x, and they want f prime at 9. So f prime at 9 is going to equal to the limit as x goes towards 9 of f of x minus f of 9 over x minus 9. Limit x goes to 9. What's f of x? 1 over root x. What's that function evaluated at 9? It's just 1/3. And you get x minus 9. Again, I can't do that limit as written. I need to simplify this, right? So what are you going to multiply top bottom minus by the minor LCD, root x times 3, or 3 root x. Let's put this down for you. Limit x goes to 9. And what do you get there? We get 3. That's not so bad. And then you get minus root x. And what do you get in bottom? 3 root x, and you get x minus 9. All right? I'm going to keep moving because I'm looking at that and saying, what are you going to do with that? There's a couple different things you could do, but I'm going to actually multiply the top by its conjugate, which is 3 plus root x. Let's put this down. Limit x goes to 9. And what do you get there? You get 9 minus x on top. What do you get in bottom? 3 root x, x minus 9, and 3 plus root x. Wow, this looks complicated. So what I'm going to do is on top, I notice that the order's not right, so I'm going to factor out a minus 1. And that would be x minus 9 now. What do you get here? 3 root x. Well, x goes to 9, but it doesn't touch 9, so these things are not 0. They cancel off. And I'm left off with a much simpler problem now, when I can use limit laws. Minus 1, 3 root x, and then you get 3 plus the root of x. Can I do the arithmetic, the limit in this? Of course I can. It's limit law problem. It's minus 1. What do you get in bottom? 3 times 3, and you get 3 plus 3. Let's be careful now. It's minus 1, and that's going to be 9 times 6, which is 54. All right, so let's keep going, and then we'll take a break. So number 10, and number 10, again, definition problem. So f of x equals 1 over x squared plus 1, and the f prime is minus 1. The f prime is going to be evaluated at minus 1. All right, let's look at it. So f prime minus 1 is a limit as x goes towards minus 1 of f of x minus f of minus 1, and that's going to be x minus a minus 1, which is x plus 1. Let's keep moving forward. What's f of x? It's 1 over x squared plus 1 minus, well, f of minus 1 is going to be 1 over 2. What do you get here? X plus 1. What I'm going to do here, multiply the top and the bottom by the minor LCD, which is 2x squared plus 1. 2x squared plus 1. What do you get here? Limit x goes to minus 1. On the bottom you get 2, x plus 1, x squared plus 1. What do you get on top? You get 2 minus, in parentheses, x squared plus 1. Let's keep moving. And again, things are going to work out. What do you get here? Well, let's take a look at that. You get minus x squared, let's see, plus 1. What do you get in bottom? 2, x plus 1, x squared plus 1. Well, I got to keep moving. And the top, really, this thing over here, it's really just 1 minus x squared, which is going to be 1 plus x, 1 minus x. That's all the top is. What do you get in bottom? 2, x plus 1, x squared plus 1. All right? What do you know? X goes towards minus 1, so x plus 1 is not 0. And by the way, they're commutative. 1 plus x, x plus 1 are identical. All right? So these cancel off, and let's write that down. And what do you get? The limit as x goes to minus 1, you get 1 minus x on top. On the bottom, you get 2 times the quantity x squared plus 1. Limit laws come in. What's the limit on top? 2. What's the limit on the bottom? It's going to be 2 times 2, which is 4. So you get 1 over 2. All right? So I think we just finished 10 problems. All right? So I know they're difficult, and I'm going to kind of break this up into pieces, by the way. So the next thing is example number 11. And so we're going to come back, we'll do example number 11. But I'll take a break now and we'll come back later. Thank you.